Hello, my name is Desmond Edagese, and I welcome you to mathematics class for today. We'll be looking at a theme, trigonometry, and our topic for today is basic trigonometric ratios. Now, in the course of our class today, here are some of the things that we will be learning. We will learn what trigonometric ratio is. We'll also find out the special angles in trigonometric ratios, angles such as what? 30 degrees, 45 degrees, and 60 degrees. And finally, of course, we'll be solving lots of problems in trigonometric ratios. Let's go into our class. Now, what is trigonometry? Trigonometry, of course, is that part of mathematics, okay, that is concerned with finding the measurement of length and angles. Right angle triangles can be solved in trigonometry making use of Pythagoras' rule and trigonometric ratios. In our class for today, we will be focusing on trigonometric ratios and not on the Pythagoras rule. Now, the ratios of the side of a right angle triangle are called trigonometric ratios. And the common trigonometric ratios are sine, cosine, and the tangent. For short, we write that as SIN for sine, COS for cosine, and TAN for tangent. The sine of an angle is the ratio of the opposite side of the angle to the hypotenuse side of the angle. The cosine of an angle is the ratio of the adjacent side to the hypotenuse side of a triangle. And the tangent of an angle is the ratio of the opposite side of a triangle to the adjacent side. Now, with respect to right angle triangle, the right angle is usually shown by a little box in the corner, somewhat like this. Okay? So the little box in our corner here tells us that this particular triangle is a right-angled triangle. Of course, the angle in question is usually written, okay, with the sign theta. Of course, it could be any other symbol, but most times we make use of the symbol theta. So we have our angle in question here, the angle we are interested in, which is our theta there. Subsequently, the sides of our right angle triangle are named as adjacent, okay? The adjacent side is the side immediately next to our angle. So we see our angle here, and we have that side. The opposite side is the side directly opposite, okay, our angle in question, which is our theta here. So the side directly opposite it is this side, and that side is called the opposite side. And finally, the side that is usually the longest, and it's also opposite our right angle. Okay, the angle that we indicated with a little box, the side opposite that angle is called the hypotenuse. The hypotenuse. So these are the three sides of a typical right angle triangle. Again, we have the adjacent, we have the opposite, and we have the hypotenuse. Now, to solve trigonometry problems, okay, we follow these simple steps. If a diagram is not given, try to create one, okay? Locate your right angle, okay? That is the angle indicated with a little box by the corner. With that location, okay, we can easily know where our hypotenuse is. We could also easily know by the angle given where our adjacent is and where the opposite is. Now that we know all our sides from the question given, we can easily pick a trigonometrical ratio that contains all the sides listed in the problem. And finally, we solve the problem. Now, these are the trigonometrical ratios we just talked about. We listed them before to be what? The sine, the cosine, and the tangent. Okay? We said they are the ratio of the sides of a typical right-angled triangle. So a sine, okay, has two sides that it is concerned with. And those sides are the opposite side and the hypotenuse side. The cosine function is a ratio concerned also with two sides of our right-angle triangle. Those sides are the adjacent side and the hypotenuse. While our tangent function, okay, is concerned also with two sides within our given right-angle triangle. And those sides are the opposite side and the adjacent side. The sine is the opposite all over the hypotenuse. The cosine is the adjacent all over the hypotenuse. And the tangent is the opposite all over the adjacent. All right? So, these are the functions. And of course, these are the sides concerned with our function. Now, to help us remember which function and which sides are concerned with the functions, we have a simple slogan known as SOHCAHTOA. SOHCAHTOA. S, the acronym, of course, stands for sine. O and H are the sides of our triangle. So, when you pronounce the acronym SOH, it sounds like a so. Also, cosine, C stands for cosine, and A and H stands for the sides that are concerned with our function, adjacent and hypotenuse. So when you join CAH, it sounds like a car. And finally, TOA, T standing for the tangent, O and A standing for the sides opposite and adjacent. So pronouncing TOA is TOA. So altogether, we simply say SOHCAHTOA. If you can remember that in your mind, you can easily know which sides are concerned with the functions, and you can easily go ahead to solve trig problems in a typical right-angled triangle. So sine theta, our angle here, is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta is the opposite all over the adjacent. We'll take some quick examples for better understanding. If you are asked to calculate to the nearest 0.1, okay, the size of theta, calculate the size of theta. Theta being our unknown angle, okay? So in this question here, we've been asked to calculate the size of theta. Let's quickly remember what we learned about the different sides in a typical right-angle triangle. We said the side opposite are right angle, that angle indicated with that little box, is called what? The hypotenuse. Okay? We said the side opposite also the angle in question, which is our theta here, is called the opposite. And of course, the other side that is closest to our angle in question is called what? The adjacent. The adjacent. So we have all our sides. Now let's try and relate which sides that will be connected to our given angle. All right, so we have the opposite side in play. We also have the hypotenuse in play. It means that O and H. Remember our SOHCAHTOA. Which of the trig functions are we going to use? S, of course, so. So S stands for sine. We know opposite and hypotenuse side, therefore it should be a sine. So we simply say sine theta, which is the unknown, is opposite over hypotenuse. Our opposite side is 8, and our hypotenuse side is 10. So 8 over 10 gives us 0.8. Sine theta is 0.8. Theta, therefore, will be the arc sine of 0.8. That is the reverse sine. That gives us 53.1 degrees. 53.1 degrees. Let's take our next question. Calculate to two significant figures the value of y and z. So here we have our triangle, we have our given angle, and we have side y and side z. Quickly first, we locate, okay, our sides. Where is our hypotenuse? The side immediately opposite the right angle. So that's the hypotenuse. The opposite side is the side immediately opposite the angle in question. So that's our opposite sides, and that leaves us with the adjacent side. So now we've been able to identify all our sides. Let's see which of the trig functions we will use first. To find y, okay, we use y, and then the side that has a value, that's our hypotenuse. So we have adjacent in play and the hypotenuse. AH. Which of the trig functions, is it the sine, the cosine, or the tan, that we will use? Remember our so, ka, toa, of course, C is the function that we'll use, ka. So C is our cosine. So we simply say cos, the angle 22 degrees is equal to, okay, adjacent over hypotenuse. Our adjacent is y, which is our unknown, and our hypotenuse is 7. So cos 22 degrees is y all over 7. If we cross multiply, y gives us 7 cos 22 degrees. And that is 7 times 0.9272, which gives us 6.5. Now let's go ahead to find z. The side z and the side that has a figure that we can use in calculating is the opposite and the hypotenuse. So what trig function, okay, can we use when we know that the sides in play are the opposite and the hypotenuse? It's the so, which is the sine. So we say sine 22 degrees is opposite all over hypotenuse. Our opposite is z, which is the unknown. Hypotenuse is 7. If we cross multiplied also, we have 7 sine 22 degrees. And that gives us 7 times 0.3746 to give us as an answer 2.6. Now let's take some more examples. The ratio of the sides of an isosceles triangle is 7 to 6 to 7. Find the base angle to the nearest degree. Okay? Of course, we know that an isosceles triangle has 2 equal sides. Alright, so we have 3 sides. 2 sides are equal. Our side here is equal, our side here is equal, and this side is different. The ratios are 7 to 6 to 7. So we have ratio 7 here, and a ratio 6 there. Remember, it's not a real number, it's a ratio. So let's assume that number to be n. Therefore, we say 7n is on the side, 7n on the other side, and we have 6n on our base. Now we've been asked to find the base angle to the nearest degree. Our base angle will be something here. Let's say that is theta. If we drew a perpendicular line to cut our triangle in half, we'll have that. Our sides, our base sides, will be 3n and 3n on either side. So let's go about our solution. Let the triangle sides be 7n, 6n, and 7n units. Let's see one side of our inner triangle. We have that to be 7n. We also have this side to be 3n, all right? And this is our unknown angle, that is the base angle. Let's see the sides in play. The hypotenuse is in play. The adjacent is in play. So we have A and H. Which trig functions will we make use of? Of course, is the C, ka, so, ka, toa. So we are making use of the cosine. Cos theta, which is the unknown, is what? Adjacent over hypotenuse. Our adjacent is 3n, and our hypotenuse is 7n. So 3n over 7n gives us 3 over 7. 3 over 7 is what? 0.4286. Cos theta is 0.4286. Therefore, theta is the reverse cos, or the arc cos, of 0.4286. That gives us an angle 64.5 0.62 degrees. Now let's take another wonderful example. A ladder of length 6 meters rests with its foot on a horizontal ground and leans against a vertical wall. The inclination of the ladder to the horizontal is 80 degrees. Find the distance of the foot of the ladder from the wall. Now remember, these questions don't have an image. Remember when we were talking about the steps? First get an image down, draw something down to make your work easier. So let's draw. We have a ladder, okay? Something like that. We have a ladder leaning against a wall. And of course, there's our ground, our horizontal ground. We're given the length of that ladder to be 6 meters, all right? And we said the inclination of our ladder against the horizontal is 80 degrees. There's our ladder, here's the horizontal. So the angle between is 80 degrees. Also, we've been asked to find the distance of the foot of the ladder from the wall. Here's the foot of the ladder, and there's the wall. So the distance we're looking for is x. From all of this, we can bring out our triangle in question. Okay? We know this side to be 6 meters. This side to be our unknown. That's a right angle, a straight wall. And then we have our angle to be 80 degrees inclined. Now we can solve for the unknown. Let's see which sides are in play. Our hypotenuse is in play, and our adjacent is in play. So we have AH. So, Toa. Which trig functions will we use? It's the C, cos. Okay, so we say cos 80 degrees is adjacent over hypotenuse. Our adjacent is the unknown BC, line BC, which we said is x. Okay, line BC, all over hypotenuse, 6 meters, that is the length of our ladder, 6. So cos 80 degrees is equal to BC over 6. To get BC, we simply do a cross multiplication. We say 6 times cos 80 degrees. And that is 6 times 0.14364. That gives us roughly 1.0 meters for an answer. Let's go on. Now, in the study of trigonometrical ratios, there are some special angles, okay, that we have. Those angles are the 30 degrees, 45 degrees, and the 60 degrees angle. They are the angles that form the triangle 45, 45, and 90 degrees triangle. That is an isosceles triangle, okay, that has 2 equal sides, okay, and a right angle, 45 degrees, and 90 degrees. And also the 30, 60, and 90 degrees triangle that could be gotten from an equilateral triangle that is split equally in half. Okay, these angles are very important because if, like we'll see shortly, we can find values for them. So if you have a problem where you come across these angles, they are ready-made values, okay, that you could use to solve your problems easily. When they are found in a trig question, the trig ratios of these special angles provide an easy way of acquiring values for them, hence simplifying our calculations. So when you have, okay, a question with these angles, without a calculator, you can easily get your answers. There are ratios for 45 degrees. For instance, if we have, like we explained earlier, an isosceles triangle where we have 2 equal sides. Let's give the values of those sides 1 and 1, say 1 meter, 1 meter. It means from Pythagoras' theorem, okay, that our side here will be what? Let's say a square is 1 square plus 1 square. Of course, that gives us 2. 1 square is 1, 1 square is 1. A, therefore, will be the square root of 2. So our A here becomes square root of 2. So we have a 45 degrees, we have a 90 degrees, and of course we have another 45 degrees. All right? Now, Sine 45 is what? Opposite over hypotenuse. Here's our opposite, here's our hypotenuse, and here's our adjacent. 45 degrees sine will give us what? Opposite over hypotenuse. Our opposite is 1, hypotenuse is root 2. So sine 45 degrees, okay, is simply 1 all over root 2. Also, cos 45 degrees is the adjacent over hypotenuse, so we have 1 all over root 2. Again, we have cos 45 degrees to be 1 all over root 2. Tan 45 degrees is our opposite over adjacent, which is 1 over 1. So we have that as 1. These are values that are more or less constant. Okay, they are used wherever we have calculations where we have angles 45 degrees, 30 or 60, as we are also going to see. We can easily impute these values whenever we see sine 45, cos 45, or tan 45. Also, if we have an equilateral triangle, like we explained earlier, that is split in two. Okay? Equilateral meaning all sides are equal. So we have 2 here, maybe 2 meters, 2 meters, and 2 meters here. If we split that, our base becomes 1 meter on each side, or 1 on each side. Of course, equilateral also means they would have same angle, 60 degrees all through. So if it splits, this side of our angle would also be 30 degrees. It means, therefore, that we would have 2 of such triangles within our equilateral triangles. We have a triangle that has 30 degrees within, one that has 60 degrees, and of course, one that has 90 degrees. The 30 degrees and the 60 degrees side or angles within the triangle are called complementary angles. That is, they complement each other. Together, they form 90 degrees. All right? We have our side 2 here, 1 here. It means, therefore, that our unknown side here, x, using Pythagoras' theorem, that would give us 2 square is what? 1 square plus x square. Of course, x square is 2 square minus 1 square. That's 4 minus 1. That's 3. X, therefore, is root 3. So that's how we came about root 3. So we have sides 2, 1, and root 3. Now let's map out our sides. The opposite side is our root 3 here. The hypotenuse side is our 2. And the adjacent side is our 1. Therefore, sine 30 degrees would be, this is where our 30 degrees is, so this side will be its opposite side. All right, depending on where the angles are, that determines where your opposite side is. So this angle in question here, 30 degrees, the opposite side will be here, which is 1 opposite over hypotenuse 2. So sine 30 degrees is 1 over 2. Also, cos 30 degrees will be adjacent over hypotenuse. All right, that's root 3 is our adjacent here, and our hypotenuse is what? 2. So cos 30 degrees is root 3 over 2. Tan 30 degrees is our opposite over adjacent. So we have opposite here and our adjacent here. 1 all over root 3. All right, so we're done with 30 degrees. Let's look at the 60 degrees, okay? Our 60 degrees, sine 60 degrees will be opposite here, all over hypotenuse. So we have root 3 over 2. Sine 60 degrees is root 3 over 2, which coincidentally is also the same as cos 30 degrees. So that's why we say cos 30 degrees is equal to sine 60 degrees, which is root 3 all over 2. Okay? Also, cos 60 degrees is adjacent over hypotenuse. Okay, so we have our adjacent here, 1. Hypotenuse is 2, 1 over 2. Cos 60 degrees is 1 over 2. Coincidentally also, sine 30 degrees is also 1 over 2. So sine 30 degrees is same as cos 60 degrees, which is 1 over 2. And finally, tan 60 degrees is opposite over adjacent. Okay, so we have root 3. Our adjacent is 1. Root 3 over 1 is the same as root 3. So easily on a table, we have all our values for these special angles, 30 degrees, 45 degrees, and 60 degrees. So we have values that we can slot into our calculations and get values without necessarily making use of our calculators. Let's run through them quickly. Sin 45 degrees is 1 over root 2. Cos 45 degrees is 1 over root 2. Tan 45 degrees is 1. Sin 30 degrees is the same as cos 60 degrees, which is 1 over 2. Cos 30 degrees is the same as sin 60 degrees, which is root 3 over 2. Tan 30 degrees is 1 over root 3. And tan 60 degrees is simply root 3. Fine. So now we know our values for the trig ratios of these special angles. Let's see how we can use them in our calculations. In the figure shown, find the lengths marked x and y. So let's treat our first figure here. We have x and we have y. So here we see our given angle is 45 degrees. So I guess you must be excited now. We have a case of a special angle which we can easily solve. All right? Let's see which of our sides are in play. Taking x first, let's solve for x. So we have x, which is our adjacent, okay? And we have 3 here, which is our hypotenuse. So we have adjacent and hypotenuse. So, ka-toa. We'll make use of our cos, c. Okay, so we say cos 45 degrees is equal to adjacent over hypotenuse. Adjacent is x, hypotenuse is 3. So we have x over 3. But remember, we have found values for cos 45. That value is 1 over root 2. So we simply impute 1 over root 2, okay, in place of cos 45. So 1 over root 2 is what? X over 3. If we cross multiply, we'd have x as 3 all over root 2. And that gives us our answer. You can leave your value like this, or you solve to get a decimal answer. Or we'll leave it that way. Also, to find y, okay, let's mark our sides in play. We have our opposite sides and we have a hypotenuse. So we have O and H. Which of our trig ratios are we going to use? S is the so, which is our sine. So we say sine 45 degrees is what? Opposite of our hypotenuse. Opposite is y, hypotenuse is 3. Sine 45 degrees is y over 3. We have a value for sine 45 degrees, okay, from what we just solved previously. And that value is 1 all over root 2 is equal to y over 3. Cross multiplying, y simply gives us 3 all over root 2, which is the same answer we got for x. Let's take another example. In the figure shown, find the lengths marked x and y. Here's our figure shown. Find x and y. Using our trig ratios, we simply know that tan 60, okay? So we have x in play and root 3 in play. X is the opposite, and root 3 is on our side, the adjacent side. To find x, we simply say tan 60, that is, opposite and adjacent, of course. Toa, t is in play. Tan, from the ratios that we derived earlier, tan 60 degrees is simply root 3. So we say root 3 is equal to x over root 3. Cross multiplying, we have root 3 times root 3, and that gives us 3 as an answer. So x is 3. Next, let's find y. Now we know x to be 3. We want to find y. All right? So we have two sides in play, y, which is hypotenuse, and x, which is our opposite side. So we have O and H. The trig function to use is the SOHCAHTOA. So we make use of our sine. Sine 45 degrees, okay? Our angle is 45 degrees, and 45 degrees is opposite of a hypotenuse. Our opposite is 3, which we derived earlier, 3, all over hypotenuse, which is y, the unknown. Sine 45 degrees is 3 over y. We have a value for sine 45, and that's 1 over root 2. 1 over root 2 is what? 3 over y. Cross multiplying, we have y is what? 3 times root 2, which gives us 3 root 2. So we have y as 3 root 2. You can leave our answer in that form or go ahead to find a number and decimal points. Let's take a final example. In the figure shown, if px, line px, is 24 meters, find line pq, okay? Here's our figure shown. Line px, from this end to this end, is 24 meters. Good. We've been asked to find PQ. Okay. This is the unknown. All right. Let's go ahead. Using the trig ratios. First, we look at the triangle PXY. PXY. That is the whole triangle. All right. We'll find that the sides in play in this case are our side here, which is the adjacent side. We have our opposite side here, and we have our hypotenuse. We want to make use of this side is important to us. Okay, so we put that in play. Let's name that side any number, say B. Line YX or XY is B. And then we know line PX as 24. So our opposite and our adjacent, okay, gives us the trig function to use as a TOA, as a what? Tangent. So we say tan 45 degrees, okay, is XY, which we named B, all over PX. PX we know to be 24. So tan 45 degrees is XY over 24. But note that from the ratios that we derived earlier, tan 45 degrees is 1. So we replace tan 45 degrees with 1. We say 1 is equal to line XY over 24. To get line XY, we simply cross multiply. XY is 1 times 24, which gives us 24 meters. So it means that this side is also 24 meters. All right? Now we go ahead in triangle QXY. In triangle QXY, the inner triangle there, let's bring that out. In triangle QXY. So we have Q, we have X, and we have Y. We have an angle here, 60 degrees. Okay? Remember what we are looking for is line PQ. PQ. We know PX, line PX already, to be 24. Okay? If we can find line QX, all right, we'll simply say 24 minus QX will give us line PQ. 24, which is the full length, minus this length here, will give us the length that we require. So we're going ahead to try to find line QX. Okay, so there's a triangle within the triangle. The sides in play are this side here. Let's name that X. And of course, our side here, which we've calculated to be 24 meters. So we have our opposite side, which is 24, and our adjacent side, which we just call X. Opposite and adjacent. Again, we make use of our tangent, tan. So we say tan 60 degrees is what? Line XY, which is 24, all over line QX, which is our adjacent. Tan 60 degrees from the ratios we derived is root 3. Okay? xy is 24, and line qx is our unknown. Cross multiplying, line qx is what? 24 all over root 3. 24 all over root 3. So we have a value for our qx. You can easily subtract qx from 24, which is the full length here, and we'll have the side that we require. So we say 24 is the full length, minus qx that we found to be what? 24 over root 3. 24 minus 24 over root 3 would have 24 is common, all in brackets, 1 minus 1 over root 3. And this is our answer. This is the way we'll leave it. This is our answer. Or we'll go ahead to make use of our calculators and get an exact value for it. And with that, we've come to the end of our class for today. But before we go, let's take a quick recap to remember all that we've learned. Today we learned that right-angled triangles can be solved using trigonometrical ratios. We said very popular ratios that we have are sines, cosines, and tangents. These are known as trigonometrical ratios. We said sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. And we also learned about the acronym SOHCAHTOA for easy remembrance of the trig functions and the sides that are related to them. Finally, we learned about the special angles. Remember the 30 degrees angle, 45 degrees angle, and the 60 degrees angle. We said that values, can be derived for those angles that we can use in our calculations for easy solving of problems. We determined that sine 45 degrees is 1 over root 2, cos 45 degrees is 1 over root 2, tan 45 degrees is 1. We also said sine 30 degrees is the same as cos 60 degrees, which is half, or 1 over 2. Cos 30 degrees is the same as sine 60 degrees, which is root 3 over 2. Tan 30 degrees is 1 over root 3, and tan 60 degrees is root 3. Now, before we go, we'll take 2 quick questions to see if we remember all that we've learned today. Let's take our question 1. The roof of a shelter is made from a piece of corrugated iron sheet that is 2.3 meters long, inclined at 18 degrees to the horizontal. How far away from the wall does the roof stick out? All right, so these are one of those kinds of questions that I told you that don't have an image. So you need to use your imaginations to draw your image first. So we have a house, somewhat like that, or the side of a building. The roof of the shelter is made from a piece of corrugated iron sheet, 2.3 meters long, inclining. Okay, so a roof is supposed to come down. All right, so we have a roof, something like that. It is 2.3 meters long. All right, is inclined to the horizontal at 18 degrees. This is the horizontal. The inclining is to that point, so we have 18 degrees. And we're told to find how far away from the wall does the roof stick out. So it sticks out from here to this end. That's the wall, x. You can easily get our triangle out, 2.3 meters, 18 degrees, and x, which is our unknown. All right? So we can go ahead to use the trig functions to solve. That's our hypotenuse, that's our adjacent. So adjacent and hypotenuse are in play. What trig functions do we make use of? Of course, is the cos. So we say cos 18 degrees is what? Adjacent over hypotenuse, x all over 2.3. Cross multiplying, x is simply 2.3 times cos 18 degrees. And of course, that gives us 2.3 times 0.95106. 2.3 times 0.95106 106 gives us a value of 2.187 meter. And that's approximately 2.2 meters. Let's see which of our options are correct. Is it option A, B, C, or D? Option C is correct, 2.2 meters. Let's take our second question. In the figure below, if line BC is 4 centimeters, find line AD. All right, so we have our figure. Line BC is 4 cm. All right, find line AD. Here's our unknown. All right, so to solve this, we'll say in triangle ABC, remember there are 2 triangles within our image, so we need to work with both of them. We have tan 60 in triangle ABC. That's our triangle. We have our angle there. That's our opposite. And we have our adjacent here. We have our hypotenuse. Okay? Tan 60 degrees is opposite all over our adjacent. These are our sides in play. So we have tan 60 degrees is what? Opposite over adjacent. Let our opposite side be line AC. Our adjacent side is 4, which is given to us, while our opposite side is line AC. Okay? From the ratios that we derived earlier, we know that tan 60 is root 3. So root 3 is line AC all over 4. Cross multiplying, line AC is equal to 4 root 3 centimeters. Okay, so our line here is 4 root 3 cm. Right, so now we can use our values gotten to find AD. Let's bring out the triangle that we are interested in. ADC. We have our 90 degrees. We have our 45 degrees. We know our side here to be 4 root 3. And we need to find our unknown there. All right? The sides in play are our opposite and our hypotenuse, which is a sine. So we say in triangle ACD, sine 45 degrees is opposite of our hypotenuse. Our opposite is 4 root 3. And our hypotenuse is the unknown, which is line AD, which we've been asked to find. Find line AD. Cross multiplying line AD is simply 4 root 3 over sine 45 degrees. From the ratios derived earlier, sine 45 degrees is same as 1 over root 2. Okay? So 4 root 3 all over 1 over root 2 is same as 4 root 3 times root 2. And of course, that gives us 4 root 6 for an answer. 4 root 6 centimeters. Let's see which of our options are correct. Is it A, B, C, or D? Option D is correct. 4 root 6 centimeters. Wow, that was a nice time. We've come to the end of our lessons for today, but I'm sure you will be with me in the next series that we will have on mathematics. Again, I'm Desmond, and I hope to see you in the next video. Bye-bye for now.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Sinforest. For more of these amazing e-learning videos, get your copy of Brain Friend, With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.